How's it going? We're going to be looking at the Unit 11 test review, first page here. As you can see, we have some space here, which, we tried to remove some problems because it has nothing to do with this unit. So, yeah, you have this extra space here. So, we're going to start off the review with number 4, not number 1, number 4. It says round answers to the nearest 10th if necessary. But for 4, this one says find the area of the circle with a diameter of 14. I just want you to leave your answer in terms of pi for this one. Okay, so the area of the circle, it's a equals pi r squared. And the diameter is 14, so that means that the radius is 7. So I'm just going to replace r with 7. So you get a equals 7 it's a equals pi times 7 the quantity squared. And then here we go, we have that 7 squared there. So it's a equals 49 pi. So you're going to leave your answer in terms of pi. I don't want you to multiply the 49 into pi and give me a decimal, because on the test, you're going to be asked to leave your answer in terms of pi. Number 5, the area of the circle is 88 square inches. Find the radius of the circle. So this one is a working backwards problem. You're already given the area of the circle. It's 88 square inches. But we should definitely write the formula out. The area of the circle is a equals, again, pi r squared. And you can see that the area of the circle is 88. So you're replacing a with 88, and you're going to equal that to pi r squared. Your goal here is to find the radius of the circle. I'm going to divide both sides by pi, and then what do you get? You get r squared equals 88, divide by pi, and you're going to take the square root because, again, you're solving for the radius, which is r. So r is going to be approximately 5.3, and this is where we're going to round the answer to the nearest 10th. Okay, so if you input the square root of 88 divided by pi into your calculator, you should get approximately 5.3 what? Inches. And then over here, I didn't do a good job putting the unit for this one because, we didn't have the unit. And don't forget, if we don't have a unit, you should include a unit. You gotta be generic on this one. You're gonna write unit squared. Since we're dealing with area, the unit must be squared. So there you go for number 4 and also for number 5. Number 6, it says, what is the area of the sector? You're going to leave your answer in terms of pi for this one as well. Okay, so get your calculator out. The area of the sector area formula. A is equal to x over 360 times pi r squared. Okay, so let's take a look at the shaded region. It is 133, and it's out of 360, right? So the area is equal to 133 over 360 times pi, the radius is 12, quantity squared. A equals 133 over 360 times 144 pi, okay? So because 12 squared is 144. And now what I need to do is I'm going to look at this. I'm going to get my calculator out. There's my calculator. I'm going to do 133 divided by 360. Hit enter. Then multiply that by 144. Hit enter. Math, enter, enter. So your answer should be A equals 266 over 5 pi feet squared, or square feet. That's number 6. Number 7, it's the same idea. You're going to find the area of this section here. So sector area formula, again, A equals x over 360 times pi r squared. A is equal to the shaded region over 360 times pi 7 squared. So then we're going to simplify that. You get something like this. All right, so now we're going to get our calculator out. 92 divided by 360, hit enter. Multiply that by 49. Math, enter, enter. So the area is equal to 1,127 over 90 pi centimeters squared. Number 8, find the area of the shaded region. Okay, so you're basically trying to find the area of the shaded region, as you can see here. And then these things, those are my unshaded region. So what do I need to do? Well, as you can see, we're dealing with, a square. Can we assume that's a square? We got to find out. This is a circle, and then this is, a semicircle. So here's a circle. We have the radius from the center to the circle. The radius is 10 meters. But if I extend that from the center to the other direction of the circle, well, that's still 10 meters. So you're basically adding the two radii together so you get that diameter there. So this, as you can see, is 20 meters. And then over here, the radius of this semicircle here is 20 meters. And so what can we conclude? We can conclude that this side here is 10 plus 10 plus 20, which is 40 meters. All right? And then, here we go. We were going to look at this semicircle again. Because the radius is 20 meters, that means that the radius from here to here is also 20 meters. And also from here to here is also 20 meters. So 20 plus 20 is also 40 meters. So yes, we can safely assume that this is a square. All right, here we go. I'm just going to erase this now. We're going to have to find the area of the square. So area of the square, that's just, side squared. So 40 squared is equal to 1,600 meters squared. And then to find the area of the circle, it's pi r squared, which is going to be pi 10 quantity squared. That's 100 pi. And then the area of the semicircle, well, the area of the circle is pi r squared, but we have half of a circle, so you need to divide this by 2. So that's going to equal to pi 20 squared all over 2. So then it's 400 pi divided by 2. And I'm going to erase this because we can simplify that to 200 pi. All right. So what do? I like to do shaded minus unshaded. So assume that the square is fully shaded, right? It's, the area is 1,600 meters squared. And then once you erase part of that, shading, you get this and this. You're basically subtracting. So the area of the square minus the area of the circle minus the area of the semicircle. So it's 1,600 meters squared minus 100 pi meters squared, and then minus 200 pi meters squared. All right, and then you're going to put those numbers into your calculator. You should get 1,600 minus 100 pi minus, I think I messed up here. This should be 200 pi meters squared here. So it's 200 second arrow. There's your pi button. You're going to hit enter. Okay, so the area of the shaded region is, it's going to be approximately 657.5 meters squared. That's your answer. And then number 9, this is really easy because it's saying use Heron's formula to find the area of a triangle with side lengths 10 meters, 17 meters, and 13 meters. Y'all, what's the first thing that we need to do? Number 1, you need to find the semi-perimeter. Okay, the semi-perimeter is essentially you adding up all the sides here. So it's 10 plus 17, or I should just say S is equal to 10 plus 17 plus 13 all over 2. Oh, this is easy. 17 plus 13 is 30. 30 plus 10, okay, well, that's 40. Divide by 2. So your semi-perimeter is 20, right? And you're going to be using Heron's formula. A equals the square root of S times S minus A times S minus B times S minus C. So replace all the S's with your semi-perimeter. And then A, B, and C are the side lanes. So A equals the square root of 20 times the quantity, 20 minus 10, times the quantity, 20 minus 17, times the quantity, 20 minus 13. And then you're going to put all of that into your calculator. So you should get approximately 64.8 meters squared. And then that's the first page of the review.